Hello and welcome to the January 2024 Recreational Astronomy Night Meeting of the RASC Toronto Centre. My name is Paul Markov and I will be your host for this evening. I hope you all had pleasant holidays and unfortunately no clear skies for us here in the Toronto area. Maybe a little bit here and there, but not a lot, and besides it was a full moon too. We are currently at the Ontario Science Centre in front of a live audience of about 20-25 people. To our online viewers, a reminder that meetings have resumed in person here at the Science Centre, so if you can next time, please join us. For those who definitely cannot make it here in person, rest assured that our live broadcasts will continue thanks to our AV team comprised of Andrew and Betty Reed, Ward Legros, and Anya Cholucci and Reza Mohammed. The last two are not here this evening, but they typically join us. And as you know, I'm always searching for presentations for future meetings. And we do have one opening for the February meeting, and subsequent meetings are wide open, and they occur on the first Wednesday of each month. So if you yourself have a presentation in mind, let me know. But also if you know of someone, if you can think of someone who has an interesting topic that they could present, please ask them or refer them to me, or I will ask them. I'm finding that folks are typically very willing to present to us, but they don't think of it until they're asked. And once they're asked, they definitely are glad to present. So I scour social media when I can, and I'll see somebody who's done something interesting, and I'll grab them and pull them in here. Just like we did with one of our presenters this evening. I saw something really neat that he did, and I thought, man, I bet our audience would be interested in that topic. So here he is tonight, and that's Benjamin. I'll tell you about that in a moment. All right, so let me tell you who's presenting tonight. We have Andy Beaton, who's going to talk to us about the sky this month. He's a regular here. We have Ed Treijs. He'll talk to us about the sky in the year 13,372. And other things to mostly look forward to. And we have Benjamin Law, and he'll talk to us about imaging with a Dobsonian telescope. And that's what I was talking about before, that caught my eye on social media, so I asked him to present. And then Tom Luton, our president, will wrap up the meeting with announcements, and we should be done by about 9:30. If you're watching us online and you have questions for our speakers, please enter it in the chat box, and tonight Ward will ask the question on your behalf to the speaker. For in-room questions, put up your hand and wait for me to come to you with a microphone. That's important so that folks online can hear your question. And show of hands here in the room, do we have somebody here for the first time, member or not, it doesn't matter. We have, a few new folks. Very good. Thank you for joining us. Welcome. All right, and that's it. Let's get the meeting started with Andy and the sky this month.
Hello, my name's Andy Beaton. I observe the universe from the streetlights of downtown Toronto. And I'm here once again to talk about what's coming up in the sky this month. I usually have this list up here, the big picture, key dates, the moon, planets, something in the deep sky, a double star, a variable star, and whatever's coming up in the world of spaceflight. So starting with the big picture, tonight at 6:30, if it were clear, this is what the sky would look like. We've got our usual summer constellations finally disappearing off into the sunset. The winter constellations coming up. You can see Orion coming up towards the east there, and just the edge of Capricornus sinking. We've got a few planets up: Saturn, Neptune, Jupiter, and Uranus. And even a minor planet. We have Eris there if you've got a really good telescope. By the next meeting, if we get up at 5:30 in the morning before twilight, this is what we've got to look at. We've got our summer constellations starting to reappear into the east before sunrise. We've got Aquila showing up just over the horizon there. Lyra's up to the east. And not a lot of planets, but we do have Venus coming along. It isn't there because it won't show up until twilight, but it's coming. So right now, here's the first error in my presentation. The nights are getting shorter, that's right. Twilight is ending around 6:30 tonight, starts just before 6 in the morning. By the time we get to the next meeting, twilight will be ending around 7 o'clock, and then starting again around 5:30. So less time for your long program photography, but more time for daylight and I guess our mental health. Key dates coming up. January 11th is the new moon. The moon is at apogee on January 29th and perigee on January 13th. That's its farthest and closest for those who haven't seen the jargon before. If you're looking for an interesting project, take pictures of the moon with the same camera, the same lens at the same time on those two dates, and compare the size of the two. You can see that there's a visible difference in how big the moon appears to us. January 25th, we have a full moon. Occultation of the star Antares by the moon on January 8th. I can't tell whether it's 9 a.m. like the Observer's Handbook says, or 3 p.m. like my copy of Starry Night says. It's one or the other. If you're interested, try both times and see which one is correct. Another occultation of Antares by the moon will be on February 5th. That will mostly be visible from Asia, not so much from here. It'll happen while the Earth is facing the wrong way. And the quadrantid meteors are peaking January 4th. If anybody was looking at the sky on the way in, you'll see that's not going to be a major issue for us. So the moon, first quarter on the 18th, full moon on the 25th. Last quarter, we got two of them this cycle, January 4th and February 2nd, and the new moon, which everybody's dreaming of, on January the 11th. We've got lunar X coming up at 4 in the morning on January 18th. And for those who don't know, the lunar X is a feature on the moon. It's the rims of two craters side by side, and at a certain time when they get illuminated and the crater bottoms are still in shadow, it looks like an X made of light on the surface of the moon. Kind of cool. I don't know if I would get up at 4 in the morning to see it, but if you are up observing anyway, it's worth a look. The lunar straight wall, which is another cool feature on the moon, which only shows up at certain times of the month, Rupus recta, if you want to look it up, on the evening of January 20th. It's a long straight feature that shows up when the sunlight's coming in from one certain angle. It's also kind of cool. So we got planets. Mercury is appearing low in the morning in the east. By January 12th, it's going to be as good as it gets this month. After that, it'll start disappearing again. The bright thing in the morning sky is Venus. Throughout the month, you'll see it. But as we get closer to February, it's going to sink into twilight as it gets closer and closer to the sun from our point of view. Mars will be emerging in the morning twilight by next meeting. It'll be too close to the sun to do any really interesting observing, but it's on its way. The big planets, Saturn and Jupiter, they're going to be up for the evening at least. Jupiter is bright and obvious and doesn't set till around midnight. January 7th is the last double shadow transit until the summer. And a shadow transit is where one of Jupiter's moons casts its shadow on the surface of Jupiter. So we have two of them happening in the same night, and that's an interesting thing to see. Saturn is getting closer to the sun. It sets earlier in the evening, and it's going to be pretty good for evening viewing. These are both spectacular objects. If you have anybody you can persuade to come out into the snow and look through your telescope, I would say get people to look at Saturn sooner rather than later, because the rings are getting closer and closer to edge on, and there'll be a few years where it just isn't as cool as it ought to be. We've got the ice giants, Uranus and Neptune. They're kind of in the middle of the evening planet group. Uranus is in Aries and follows after Jupiter. It's visible until after midnight. Neptune is closer to the sun. It sets earlier. It's further away. It's not really a good time to look at Neptune. You're not going to see much. I don't think you'll even see its bright moon Triton. I think it's going to be low enough in the sky that even that is going to be ruined. Then the dwarf planets, Pluto and Ceres, both of them are too close to the sun right now. Eris, which is one I've been tracking in my presentations, it's also out of the picture. But if you're a photographer with a decent telescope and you can manage to image 17th magnitude objects, Makemake in Coma Berenices is visible and should be imageable. So I always like to throw in something in the deep sky. What I've picked this time is Messier 78. And Orion's up there, and yeah, there's the big Orion Nebula. We've all seen it. We all know it. I'm looking for something a little bit different. It's an 8th magnitude reflection nebula in Orion, and it looks something like that. I mean, that's the European Southern Observatory, so your view may differ. But the important thing to note is the blue color, and what that tells us is we're looking at a reflection nebula. Starlight is bouncing off 10th and 11th magnitude stars in the nebula. It is part of the Orion B molecular cloud, one of the massive clouds. It's not the one with the Orion Nebula in it, it's the one around it. And it is part of the Messier list. And if no one has told you about the Messier list, these are 110 objects or so observed by Charles Messier in the 18th century. He made a list of things that looked kind of like comets to him, so he would stop reporting comets to the king. If you have recorded observations of them all, you get pins, you get certificates, and everybody will admire you as a skilled observer. So there we go, there's M78. The stars don't really show up in this image. They're kind of so bright, they're kind of blowing out in the middle there. If you're looking for something a little more challenging, as long as we're in this same molecular cloud, we have the Horsehead Nebula, also known as Barnard 33 if you like to keep detailed notes. And it looks like this. Another one of those images that you see everywhere. For that one, you want dark skies. A nebula filter helps, a filter that cuts it down to only hydrogen alpha light, and probably a telescope 10 inches or bigger. I have to confess, in all the years I've been observing, I haven't seen it myself. It's not an easy object. It is a difficult one for the eyeball, much easier for the camera. For those who are wondering, it's a cloud of dark gas between us and brighter clouds of gas in the background. So if you look at it, kind of see a 3D effect. It kind of looks like it's in front of the cloud of stuff behind it. So as always, we have comets and meteors showing up. The quadrantids peaking January 4th. That's actually the morning of January 4th, so that's tomorrow morning around 5. It doesn't look like it's going to be good. 120 meters an hour for those who are not under a giant bank of clouds like we are. If you are under a giant bank of clouds, there's always another option, and that is to do some radio observing of meteors. If you get your radio and tune it to a distant station, something way out of our range, I don't know, maybe something from California or something, wait for a meteor to pass overhead. It will create an ionized trail in the sky that will last for a few seconds, and for that brief period of time, you can pick up a radio station way out of your range. And by counting the appearance and disappearance of those radio stations, you can get an idea of how many meteors are going overhead. So we've got a minor shower going on as well. The Coma Berenices, that's more like 5 to 10 meteors per hour. And we've got some meteor dribbles, the Alpha Hydrids, Gamma Ursa Minorids, and the Eta Corvids. These ones, you're probably looking at 1 or 2 meteors per hour. I wouldn't go outside to look for them, but if you are outside and you see a meteor and it's not pointing anywhere for any of the known meteor showers, try tracing it back and see if it's one of these very minor meteor showers. We have comets, 62P Tsuchinshan. I'm hoping I'm pronouncing that right. Currently 8th magnitude in Leo. It's on its way out, so if you want to see it as soon as possible. It's only going to get dimmer as it goes. We have a couple of less spectacular ones, 12P Pons Brooks in Cygnus, and H2023 H2 Lemon in Grus, just over the southern horizon from here. I know that we sometimes get people showing up to this talk from the southern hemisphere. If you're down there, check out C2021 S3 Pan stars, currently 11.5 in Centaurus. Now, I was checking on spaceweather.com earlier, and I didn't see anything interesting or spectacular going on tonight. But we are in a solar cycle where activity is on the rise, so we should be seeing more sunspots and more prominences in the day, and hopefully more aurora at night, especially the closer you get to the North Magnetic Pole. If anybody is watching from Iceland, this will be good news for you. There will be all kinds of stuff coming up. So I still like to do double stars. Iota Cancri is the one I've picked tonight. It's a double star in Cancer, yellow 4th magnitude and a blue 6th magnitude star. 31 arc seconds apart, so it's an easy split. Just about any telescope should be able to do it. It's not one where you can measure the orbital motion over time. I like those ones where you can take a look at it and go back 10 years later and see that they've changed position. These ones, not so much. But they do seem to be traveling together through space. So as far as we can tell, they are a real double star. What's more interesting about this pair, the A star, the brighter of the two, has excess barium in its atmosphere. And what I'm told that means is there was probably a third star in this set, which has blown up, disappeared. Something has happened, and it has dropped most of its atmosphere into the atmosphere of the other star. So it's a possibility there's an unseen white dwarf still traveling around with this pair. I suspect we're not going to see it with our own telescopes, but careful observation, maybe you might see some kind of motion of one of the stars that would be unexpected. People who have heard me talk here before know that variable stars are my passion, and you're not going to get away with not hearing about one tonight. Argem Minorum is my pick, and it is a classic Myra-type long-term variable. And what that is an older star that's in its last days. It's dying. It's not generating enough energy in its heart to keep its atmosphere pushed out. Gravity pulls it in. As gravity pulls it in, we get a bit more gravitation pressing on the center. It heats up again, it pulses out again, and the cycle continues. And this goes on for 369.91 days, very well measured for this one. And the magnitude goes from 6th to 14th, which means at the peak, you may be able to see it with the naked eye. At its dimmest, you probably need a 12 or 14-inch telescope to see it. And it is part of the AAVSO legacy program. And what's going on here, I know we're all aware that robotic sky surveys are now a thing. You know, they set up a telescope, and every 3 nights it photographs the entire sky, digitizes it, and dumps it into a giant database. And people have asked me, and I have asked people, does that mean variable star observing is obsolete? And the answer is, in some ways, yes, but in other ways, no. The legacy program is an effort to have consistent data recording going back to the early days of the AAVSO, back to 1911 when this database started. So what they want, they've got all these brand new observations from the sky surveys, but you also want to know how it compares to observations from 1915. And the observations in the legacy program give a baseline so that we can use consistent observations all the way back. So this is the value to these observing these long-term variables, even at this late date with the old Mark I eyeball. If you're interested in observing variable stars, and everybody should be because they're fascinating, aavso.org is where you go for maps and where to report your data when you observe. Now, one last time for another variable star, SN 2023 IXF, the supernova in M101. We've been watching it for a while. Currently, it's down around 16th magnitude visually, and it's been sinking for the past month. So I think as far as we are concerned, we're pretty much done with this one. It's on to the professionals for now. I think the amateur community has done its work. So we have stuff coming up in space. January 8th, we have the Peregrine commercial lunar lander launching. This is a test for a lunar lander which will be exploring and leading to future commercial operations, whatever works out to be the most valuable money-making proposition on the moon. We'll see what that is in the far future. Axiom Mission 3, manned Dragon capsule going to the ISS on January 17th. If you're watching for the ISS, this would be a good time to look for it because you can often see the Dragon capsule as it catches up to the ISS and docks, just for extra spectacular fun. The Juno mission just passed the volcanic moon Io around Jupiter and will pass again on February 3rd. Let's keep our eye out for spectacular images that I hope are forthcoming. The ISS is passing over us until January 6th in the morning, and then from January 14th to February 4th, it'll be passing over in the evening. Heavensabove.com is where you go for times and locations if you're not precisely right here in downtown Toronto. And of course, we're still getting fascinating JWST images. This is one I found. This is Uranus and its rings in infrared light. I think that's pretty spectacular, the way the rings are lit up there. So keep an eye out for more interesting stuff coming from the JWST over the next month. Now we have one more spaceflight highlight, and this is not for us. This is for anybody watching us living out in the prairies. The Japanese probe Hayabusa 2 is on its way to grab material from an asteroid in 2026. They don't have a sufficiently precise orbit for the asteroid yet. So if you're in the prairie provinces, the asteroid will be occulting a 12th magnitude star on January 6th at 2:22 Universal Time. If you can, try and get an observation of the occultation. The link is there. If you're interested and need more information, contact me offline and I will get this link back to you. And what if it's cloudy, like it's been for about 6 months now? Zooniverse.org, lots of citizen science projects where you can sit at your computer and poke away at analyzing data, tons of astronomical data. There are more than any individual scientist can cope with, so they farm it out to people like us. Four that I've picked from the vast number at Zooniverse this month were kilonova seekers, a daily minor planet, disk detective looking for planetary disks around distant stars, and Galaxy Zoo, the one they started with, now has JWST data, infrared images of galaxies, which will probably provide information that no one has ever suspected we'd see. And if you are interested in Zooniverse, there is an app available for your phone or your tablet, iOS or Android. I don't think BlackBerry is out there. And this is what I have. If you have any questions, corrections for the inevitable typos, you can email me or find me on some of the social media networks. Thanks very much.
Thank you very much, Andy. Do we have any written questions? Let me grab my phone. Where's the mic? Was there? Thank you. All right. One question right here.
For the radio detection of meteors, would you use AM, FM, or does it not matter?
I've been told both AM and shortwave work. I guess in theory, shortwave would work best because I know it bounces off stuff in the ionosphere. But you know, if you only have an AM radio, you'll give that a shot.
Any questions online? Nothing? We have one in the room here.
You mentioned the Bernard, Bernard. How does the cloud form like that? How does it form?
How do clouds like that form? I guess it's that's actually a fairly deep question. When galaxies form, and we're talking back at the dawn of the universe, we get a lot of hydrogen getting pulled together by self-gravity. You know, enough hydrogen gets together, it kind of pulls toward itself. And not all of it gets formed into stars. A lot of it is just floating around free-floating clouds of gas and dust in our galaxy. And that's what we're looking at here. We're looking at basically clouds of hydrogen dating back to the earliest days of the universe. So the fact that it looks like a horse head is just a wacky coincidence, just people making images out of random shapes. But how it forms is just a very primitive hydrogen and gravity.
Okay, any more questions in the room? No? Okay, good. Thank you very much, Andy. Appreciate it. As always, great presentation. And we're going to take a short break while we switch equipment for our next presenter, and that is Ed, and he'll talk to us about the sky in around the year 13,000 something.
Yeah, good evening. So my presentation is titled The Sky in 13,372, Other Things to Mostly Look Forward to. In a sense, this is actually a retrospective because it's bits and pieces of presentations that I have given before, one of which was in a blizzard when we were doing our recreational astronomy nights at York University. So I'm thinking some people may not have seen this before, or they may have forgotten it, and like the next day you go, oh, this is interesting, at least so I hope. Okay, so I'm going to cover basically three different kind of subtopics in this kind of portmanteau. Like I say, it's like a few different presentations. We won't call it a Frankenstein presentation. So we're going to talk about the moon's orbit in 2024, 2025. We'll take a look at some planetary gatherings of interest, and then we'll look at the weird and wonderful far future. So RASC members, as you know, you always get the Observer's Handbook, and the Observer's Handbook is actually got, even the parts that you might think are boring are probably worth looking at, because sometimes you learn something and go, hey, I didn't know that. I'm still trying to digest the whole binocular and eye relief and pupil diameter stuff. It is extremely detailed, but we're going to talk about something a little bit different that I do understand. So in the moon section, which people might skip because, you know, the only thing is the moon is like up there and get out of the sky, please. This is actually a quote from part of the handbook, and there's a lot more interesting information, but we're just going to excerpt it. The moon's orbit is tilted some 5 degrees to the ecliptic, with the nodes crossing points of its orbit regressing rapidly, and regressing means it's moving along. In 2024, the effect is additive, with the moon having a declination range from plus to minus 28.1 in January, increasing to a range of plus to minus 28.7 in September and October, flattening out as we approach the major lunar standstill of 2025. And yes, major lunar standstill is capitalized. There's a Wikipedia article on it. That just means the moon is like basically at its extreme high and low point, or a more extreme orbit. So this is from page 159, and there's a bunch more interesting information, like our moon is quite unusual in the solar system for not being on our equator, being on the ecliptic, so kind of traveling with the other planets, which means it's higher at some time of the year and it's lower at other times of the year, at least when you notice it. So People know that in winter, the full moon is like way up in the sky, but the full moon in June, well, it hits your eye like a pizza pie maybe, but it's quite a bit lower. So that's the effect of the moon not following our equator, and this effect actually can subtract or add to that. So what's it mean? For the next couple of years, and that's 2024 and 2025 basically, the moon will be both as high and low in the sky when at the meridian, which is when it kind of stops rising and starts setting, as it can possibly be. The Observer's Handbook does, on the same page, have a handy table of the moon's passages through the high point at about 6 hours right ascension, which is in the constellation of Taurus. And vice versa south of the equator. So if you're looking at the moon from Chile, the Observer's Handbook table of the highest passages for you would be the lowest passages. However, what I think is more interesting than just, oh, well, this is the high point, is if we can actually go out and take a look up in the sky and go, holy moly, that moon is way up there. So rather than just the plain day, because if you go out at the wrong time of day, it might be rising, it might be setting, it might be low on the horizon. I actually went and played with stellarium for a while to actually get the times when it's actually the highest in the sky. So if you go out at that precise time, that's about as high as it will get. You can go, this is pretty impressive, hopefully. The following table, which I did myself based kind of on that table in the Observer's Handbook, it's the highest moon viewing opportunities for Toronto, so the times will vary elsewhere. If you're in Calgary or St. John's, it'll be a different time. You'd have to figure it out for yourself, maybe using stellarium. The lowest moon, which is the highest moon in the southern hemisphere, will happen like 2 weeks on either side. So just as the moon goes around in basically 4 weeks, 2 weeks after it's as high as it can be, it's going to be as low as it can be, but I haven't really called that one out. So here's the table. People want to take a picture of that, or I'll probably post it to our forums. And later on, I'll probably come back at the end of my presentation and put it up if you want to write it down. So for instance, this month on January the 22nd, if you go out at 10:20 p.m., give or take a few minutes, you'll see the moon as high as it can possibly be. That's when it'll be like pretty much due south. These phases that I have listed there, those are actually taken from the Observer's Handbook. So a high phase waxing gibbous, that sounds pretty impressive, doesn't it? It means it's gibbous, which means it's past quarter moon, but it isn't full moon yet, but I'm not quite sure what high phase means. So what happens is that each month, the high point has actually got a slightly different phase, as you can see there, because every month the moon passes through that time about an hour earlier or so, a couple of hours earlier. So February the 18th, moderate waxing gibbous. And you can see it gets earlier. So January, February, and March are the times we can see it in the sky. March would be kind of in early evening. In April, it's pretty much in daylight. And then I skipped all the ones where it's high in the sky during the daytime because I don't think that's quite as interesting, but you can go look that up as well if you want. It will also be quite a bit thinner when it's in the sky during the daylight because it's close to the sun, so it'll be harder to see. In my opinion, it wouldn't be quite as spectacular. Then once we come into the autumn season this year, September the 24th, last quarter, if you're up at just before 7 a.m., and it comes through and it becomes closer and closer to full and earlier in the night, or not as early, I guess I would say. So for December the 16th, it's pretty much the full moon, and that's probably spectacular if it's clear. If there's snow out, it would be like lighting everything up because it will be extremely high in the sky. It'll be almost 75 degrees up, which means it's only 15 degrees from the zenith, which is, as I say, unusual because once the moon's orbit moves on, it's not going to make it that high. And that's why I added in the December the 15th and the 17th on either side, because it'll still be pretty high and it'll be quite close to the full moon. So hopefully people will get a chance and go out. Like I say, you want to do it on that specific time. Hopefully it's clear. Okay, so next we'll take a stellarium tour. Jumping off from today's date, we're going to go to 1942, and I'll explain why when we get there. We'll go to 2025, and that is next year. I had to change that from 2024 being next year, and I went, wait a minute. So welcome to almost a quarter of the way through the 21st century. And then we're going to go to the year 13372. Again, I give a shout out to Stellarium. It's a free application. It's open source software that is provided for free. So you go to stellarium.org, you download it, and you can do a lot of really interesting poking around in the sky using Stellarium. Okay, so here we are in Stellarium. I don't usually use a mouse, so bear with me. So right now the time is pretty much today. As you can see down here, we're here and now right now, so I'm going to just freeze time because it slows it down a little bit and makes the CPU run a little bit better. And this is pretty much what Andy told us. He didn't lie to us. There's like Jupiter up there and Orion is coming up. It's a little after the 6:30 that he had for his big picture. So we're going to call up the, double click that, maybe. Oops. Oh, that's interesting. Oh, there we go. Excellent. Well, yeah. And it is fairly hard on CPUs, but I'm running a laptop that was a refurbished laptop purchased 10 years ago, and it still runs, and the latest version does run, so it just takes a long time to load. Sorry, I'm having some issues seeing the keys here. Very good. So now we're in the year 1942, which honestly, in the terms of history, was not a very good year for a really lot of people. World War II was well in swing. Lots of bad things happened there. But if you were in Toronto and it was clear, take a look overhead. You've got Jupiter and Saturn and Mars in a beautiful lineup. Now, if we go over to the west, we don't quite see too much there, but let's just run time back. And there's Venus as well. So on this date in 1942, if you went out there at, I don't know, that's like 6:11 p.m., you would see 4 of the planets spread across the sky, and the 4 bright planets. And here's the other kind of neat thing, is if we run the date forward, Venus gets closer to the sun, but, whoops, there we go. Mercury also shows up there, so later in that month of January 1942, all 5 planets would be visible if you had a clear sky. All 5 of the classical, well-known planets would have been visible in the sky. So that's kind of neat. I'm not entirely sorry. I don't think that I missed that, because like I say, 1942 was a pretty crappy year for everybody. But these planetary gatherings do come up, and the reason I know about it, by the way, I'll put in a plug for the library at the Carr Astronomical Observatory, the Troyer Library. They have the observers' handbooks and the journals from way back in the past, and I just came across that randomly just browsing stuff. So, like, you never know what you're going to find until you go look. So let's go back to today. So we're back at today at 2014, and we're going to go forward just 1 year. Whoops, go forward, there we go. So this time next year, we actually have an interesting proposition as well. There's Venus. Saturn isn't that bright. Oops, there we go. Saturn is kind of dimmish at magnitude 1 point something, but Venus, of course, is conspicuous. And if we go up into the sky, there's Jupiter pretty much overhead, and it's a nice, bright, distinctive one with all the bright winter stars. And we also have, where did it go? Here's Mars coming up, and Mars next year is actually going to be quite bright. It's minus 1.31. So next January will actually get 4 bright planets in January, so that'll be kind of a neat view. I will say that Mercury is lurking on the other side of the sun. You'd have to, or the other side of the sky. It's an early morning planet, so Mercury's kind of avoiding this one. It's possible that if we go forward or backward in time here, we might find Mercury in the same sky, but I don't think so. So that's kind of something to look forward to in the short term, same as we can see the moon like really high overhead, and instead of cursing it, go, wow, that's pretty fun. So the last thing we're going to do is going to take a trip into the far future. I'm going to go back to today. So does anyone have a guess, and I know there isn't a microphone there, what the sky will look like in the year 13,372? At least according to Stellarium. Yes? Same as 1942? No, it won't be same as 1942. Ooh, someone wins a prize, I think. And it's not just that, but there's going to be some other big changes. So people who are familiar with what's going on, and like I say, I'm going to put it to right now, and people are fairly familiar, sorry, I don't mean to, don't tune in too closely or you'll get dizzy. I'm going to throw in the constellations. I think that's the lines. There we go, and this is again is what Andy showed us before. So you'd think you'd see something pretty similar, but nope. I'm going to just scoot this guy out of the way. In fact, we have Scorpius, which we here assume is a summer constellation, and Sagittarius, and they are way up in the sky, way more than we would ever see them here. In fact, this star here, it's called Rigel Centaurus, but it's also Alpha Centauri. And that's the closest neighbor to the sun, and generally right now we do not see it from Canada. You'd have to go, I don't know whether you'd even see it from Florida, maybe. You'd have to go a long way south to see it. And even better, this is the Southern Cross, or the Southern Cross, and it's actually over our horizon in winter in January 13,372. Now you might say, how come Scorpius and Sagittarius are there? This doesn't quite make sense because they're visible. The sun should be there. And that's a question that if people are wondering that, you can ask me during question period. I'm not going to go through all the details here. So what's happening is just like the moon's orbit kind of wobbles, and the moon's orbit wobbles in pretty short order, like 18 years. So in 18 years, it's going to be high again if you want to wait until 2042. The Earth itself, it's tilted, we know that, that's what causes the seasons. The Earth itself wobbles like one of those tops that you put on the table and spin it up, and it does this. So it's a bit of a drunk wobble, and it takes about 26,000 years, so 13,372 is like halfway through the cycle. And what I will demonstrate, and someone in fact did say it correctly, we're going to pull up the grid of the sky. So we're looking south right now, and we'll pop around to the north. And here we go. Instead of Polaris being the pole star, it's going to be pretty much Vega. Vega is going to be less than a fist's width from the North Pole. It's going to be a bit further away than Polaris is right now, but Polaris is, in that year, Polaris will be quite a distance away. Where is it? Somewhere here. Oh, it's actually down here. Or is it? Yep. Yeah, there you go. So the other interesting thing is that we've gained something. We've gained the Southern Cross. We've gained that whole center of the galaxy, and Centaurus is all now nicely up in our sky instead of just scooting over the southern horizon. However, and here's kind of the problem or the disadvantage, if I go forward to to June, so summer. So now it's light at whatever we're at, 8 p.m. because this is June. You know, the summer days are longer, but let's just get into night. So Vega is still up there, but if we go to the south, look at that. Remember this fellow? That's Orion. So we're going to run time a little bit backwards. Whoops. Nope, that's not what I meant to do. So basically, you might be able to catch Orion's belt briefly at the very horizon. You're not going to see Rigel, and as far as seeing the bright stars like Sirius, yeah, forget it. So what happens is we've gained a part of the sky because the Earth has wobbled that way, but we've lost another part of the sky. And the overall scheme, and the easy way to think of it if you kind of know your way around the sky, is anything that's in the winter sky right now is as high up for us as it can be because the Earth is tilted that way. And anything in the summer sky is as low as it can be. And then, so that means that Orion is a lot higher than it will be then, but everything that's in the low summer sky, like Sagittarius, moves way up as we wobble around and face different directions. So this is something probably you can't see directly, but this is kind of the fun of playing with stellarium, especially if you have a cloudy night. You can play around with it and see what's going on, because some of these things are pretty neat and it's not really very intuitive. Just to finish up, because I don't have that much more, I just encourage people to go out and try it. You can see there's a whole different set of stars that are circumpolar. So circumpolar stars are ones that never set from a particular place, and in Toronto it's like 45 degrees on either side of the North Pole, never really sets. It might get really low on the horizon and it comes up because it's just circling Polaris, which is a ways up in the sky. Now things have become circumpolar, like while Cepheus is still there, but stars like Altair are now circumpolar, which would never be the case now. Now it's kind of a summer star. So things really change around quite a lot when the Earth wobbles, and the effects are not necessarily what you would expect from just saying that Vega is the pole star. There's a lot of knock-on effects because the sky is still similar, but it's been tilted in a way that you'd go, what's going on? So kind of neat. And that is pretty much my presentation for today. Like I say, it's some bits and pieces that I've shown before, but I am open for questions. Which I hope I can answer.
Thank you very much. Very intriguing. So the whole notion of summer-winter constellation gets turned upside down, and we lose the Orion Nebula. Okay, we have a question over here.
As far as I can see, the constellations are still the same. They're just in a different part of the sky. So how long will we need to wait for them to sort of start dissolving and rearranging?
Okay, so actually, and this is the one thing that I don't think stellarium really does, is the stars are in fact changing their position in the sky. So 50,000 years ago, I think, or so, the Big Dipper, which is a very familiar sight to us, was shaped quite a bit differently. Yeah, so stellarium doesn't actually show that. There's probably going to be more distortions in the various constellations than this really shows it, because, I mean, this is a free program and we're running it for, I can't imagine how much calculation it would need to say, okay, we're getting close to the star. For instance, one interesting thing that I've read, and I believe this is true, is we are also approaching the star Vega, so it's probably going to be quite a bit brighter than what it by then than it is now, because this program says, I believe it is actually saying it's the same brightness as it is today, and I think it will be brighter because we're moving in that direction. We're getting closer to Vega. So from the point of view of the precession of the equinoxes, the program is correct, but from the point of view of how individual stars might change and shapes of constellations might change, especially ones with stars that are close to us so they can move apparently faster, it doesn't really show this. You could run it forward 50,000 years, and I don't know what it would show. Probably just take us around in a cycle. But I haven't tried it, so that's something that you can try.
And speaking of far future, do you think by year 13,000 we would encounter the first alien civilization?
13,000 years is a long time from now. 13,000 years ago, I'm not sure anyone was living in North America because I think most of it was covered in glaciers. So that's an open question. I don't know what the answer is. Right now, we're finding that the universe is awfully quiet, though, quieter than we are. Why is that? Who knows?
Yeah, okay, well, you talked about 13,000. Now, I was just wondering about what it would be like, say, about halfway in between, say about 6,580, what would it look like?
Your request is my command. See, this is the fun of Stellarium, right? You just punch it in and you can see, what year would you like, 6,500?
Yeah, somewhere around halfway in between.
Sure.
yeah.
There we go. So neither Vega nor Polaris is going to be close to the pole, that's for sure, because the whole circle is halfway. In fact, like it looks like the pole star is in the middle of the constellation Cepheus, the king.
Kind of like what the
If we-
South Pole looks like now, in a bit of a sense.
I'd have to change the
Sense of no
location.
Central star.
Yeah, so what we also get is you can see, actually, so just to see what we see to the south, I'm going to put it to about midnight, so it's going to be, so some things won't change very much because they'll be kind of averaged out. But if we go and we just go through the months, and I'm going to just zoom out, so it looks like Virgo is going to be a bit lower in the sky. That's the constellation Virgo there. But let's just step through. Well, I'm going to run back to January. So Orion's been hit a bit, but not that much. Sirius is still up, so I predict that something on the other side of the sky will be a bit more different. We'll always see stuff that we don't really see very much, but let's see. I mean, you ask a very good question, and this is the sort of thing that you have to play with to see, because there's like a million different possibilities, and it is not intuitively obvious if you know your way around the sky right now what it will look like later. So Scorpius is already getting higher in the sky, because usually in Toronto, that stinger part just barely scrapes our horizon. You can see the stars if you're looking over Lake Ontario and it's clear. But you're getting constellations like this is the constellation Grus. And although Andy mentioned a comet in Grus, it would be in the northern part. But these two bright stars in Grus we really don't see from Toronto. They are just below our horizon. It's already coming up. This nifty thing is the constellation Phoenix. It doesn't look like that. I've been to the southern hemisphere, and no, I couldn't see the jet fighter. So yeah, you're getting already stuff coming and going, but like it's most dramatic when you do the opposite, right?
Yeah,
And-
it seems like Orion is kind of somewhat circumpolar at this time.
Right, so I mean, from now on, Orion will actually be getting lower in our sky, pretty much from now on, but I mean, you'd have to look every 1,000 years to really notice it, but it will be dropping down until it's just like halfway up. Half of it's up, and that's it.
Thank you.
Thanks, that was really interesting. But it did make me think, like the JWST, not affected by precession. But then I thought, wait a minute, the Lagrange points are going to change because of solar precession of the ecliptic. I mean, is that something that you thought about, or how that would affect the?
You know, I haven't thought about that, but actually just the moon's orbit changing around the Earth would change where the JWST is, because you're right, it's in a Lagrange point. I'm not quite sure, I'm not enough of a spacecraft expert to know how that works, but I would trust that they've taken that into account. But you're right, it would mean that the JWST is at a different location relative to the Earth at a certain time over in fact, the moon's orbit cycle of 18 years. It's going to wobble. Yeah, but 26,000 years. So like in each year, you're going to see 1/26,000th. That's probably not that much to worry about compared to the moon going up and down 5 degrees over 18 years. Yeah. You're welcome.
Do you have any questions online? Yes.
We have a question from Frank Dempsey. Will the moon still be visible in 11,000 years, or will there be too many satellites overhead?
That's a philosophical and technological question which I feel unable to answer at this point. I would hope that we don't have a Death Star orbiting, because that's the only thing that would be bigger than the moon, I think. But the moon's still pretty bright.
Okay, great, and that's all the questions we have.
Good. Any questions in the room? Nope. Okay, great.
Thank you.
Thanks again. And we're going to take a short break while we switch to our next speaker.
Good evening, everybody. Thank you for having me this evening to share my hobby with every one of you. And the previous presentation was so interesting that, I was imagining, like, would Betelgeuse still in the sky in 6,000 years or 13,000 years later? Or, would Elon Musk just put all the satellites in the sky and just mess up all the constellations? It's always interesting to look at the sky. As a kid, I always wanted to look at stars. I think I shared before in my last presentation that my first object that I looked through was Saturn through a 3-inch telescope, and it just blew my mind, and it totally changed my way to look at the sky. And I grew up in Hong Kong, and it was a big city, and there's actually no star in the sky except bright planets. And when I and my family decided to come to Canada in the early 90s, when I was a teenager, I realized the sky is actually dark. I can see lots of stars. Even though I was living in North York, but I could see stars and stars in the sky. And so fast forward, many years later, when my kids were a little bit older, I still love observing, observing the sky as an amateur observer, but I started taking pictures in 2016. So that was my hobby since then, and I just love challenging myself in taking pictures of using different types of equipments. So the topic tonight, I would like to share with you how I use a Dobsonian telescope to take pictures, especially take pictures of an artificial, satellite or ISS. Okay, so I will show you how what challenges that I had to overcome to take some of the pictures. So when I started this hobby about 8 years ago, I got into different types of photography, like wide field, deep sky object, planetary, and solar photography. When I look at this solar photography picture, the first thing in my mind, in 3 months and 5 days, our moon will be covering this star, and that will be spectacular. So I already make plans for that day. I don't know about you, but it is going to be once in a lifetime opportunity. I saw the last eclipse in 2017, and it was amazing. So this time, hopefully, we get good sky, and we can actually witness the solar eclipse in this year in April 8th, but not in Toronto. So I think the closest place will be somewhere east along Lake Ontario, the near Kingston or Prince Edward County. Yes, it was right in the middle of the path. So, Dobsonian. So, well, before that, just quickly talk about, if you want to do wide field astrophotography, you probably just need a tripod, or if you can have an equatorial mount or an azimuth mount. So that is the kind of mount that just go horizontally and vertically, or an equatorial mount that can actually track the star. But basically, a tripod can do picture like that. It's very easy. And if you want to do some deep sky object astrophotography, you would like to have an equatorial mount. Sometimes the alt-az mount may work, but not as good as the equatorial mounts, because deep sky objects, usually they're smaller. You need a very, very good tracking on it, and without any what we call the field rotation that the alt-az mount will provide. Planetary astrophotography, you need a long focal length telescope and a very sensitive camera. For solar imaging, of course, you need a solar filter. You cannot just take the picture of the sun without any solar filter. That would damage your equipment, and that may damage your eye as well if you look directly through a telescope without any protection. And Dobsonian telescope is actually a Newtonian telescope. But this telescope is actually more popularized by John Dobson in 1965. And the design is very simple, Newtonian reflector on a very stable platform. And usually we say that Dobsonian telescope has a very good aperture to cost ratio. Because if you actually shop around different telescope, of course, the bigger, the more expensive. But Dobsonian telescope actually has the very good aperture to cost ratio because of the simple design, and relatively, if you pay the same amount of money, you will get a larger aperture, a larger diameter, a larger size of the scope. So for observation, it is great, it is amazing. 8-inch Dobsonian telescope without tracking mount, it is relatively more affordable than an 8-inch refractor, for sure, or 8-inch, other type of design telescope. Dobsonian is very economically possible for many, many beginners as well. And, sometimes when I interact with people, what is the best, first telescope you could buy for teenagers or for new astronomers? I would suggest a tracking or go-to Dobsonian telescope, because it is actually a very easy device to use for any beginners to, first of all, know about the sky, but also they can actually select, the mini computer there, and it would just lead to the right direction and find the right target. So it is a very, very handy feature. My Dobsonian telescope I got about 2 years ago. It was on sale, big sale. I don't know why they were on sale. I was just taking a chance. But yeah, it was a big sale. It was a 14-inch tracking Dobsonian telescope. I regret it a little bit after I got it. After I saw the box shipped from the supplier to my house, the box was huge, because this telescope actually is about 150 pounds in total. The base is 94 pounds. The OTA, the tube itself is 53 pounds. The total is about 150 pounds. And I couldn't fit this into my vehicle as well. Not even the trunk, not even the back seat. I can only use it in my backyard because it is just humongous. So, so far I haven't taken this telescope away from my backyard, but how did I move it around? Many people ask. Doggy from Canadian Tire with some bungee cords that can yeah, I can move it around in and out of the shed in my backyard. So right now, it's been cloudy for the last many months, and it's just sitting in the shed without doing anything. And on top of observing, I use my Dobsonian telescope to take pictures of planets, which I will show us some of the samples at the end of my presentation. But I want to show you today about this very interesting possibility using a Dobsonian telescope is to take pictures of ISS, International Space Station. My photos are not that great, relatively, but I was so happy that I got some decent photo, and I can show you my progress from my first trial last year, and then less than 2 years ago, and then up to this point, what I have got so far. This is my latest ISS photo. It is not the clearest, but I'm so proud of myself to get like one of these after 12 attempts this year. And so you can see the solar panel here, and there are different names of the parts, and these are the solar panels as well. Well, the challenge of taking ISS is that you know that it is orbiting around us every 90 minutes, and it is moving pretty fast in the sky. So, you know, ISS is moving, and you know, if you remember the movie Gravity, you know, George Clooney was setting up the stopwatch for 90 minutes because everything at that altitude above the ground has the same orbital period for around 90 minutes. And ISS also has a similar orbital period, about 90 minutes. It goes around the Earth every 90 minutes. And the size is about the size of an American football field, about 100 meters length and 73 meters width. For imaging, I think what I found is that the higher the maximum altitude, that is what angle, you know, imagine the ISS is actually moving across the sky like that. What is the angle above the ground at the maximum altitude? The higher above the ground, the better it should be. Because if the ISS is low in the sky, there is a much thicker atmosphere between you and the space station. So when it is much higher up in the sky, the amount of atmosphere is actually much shorter. And you could actually get a better, clear picture, and also it is actually closer to you. It's actually closer to you. So to get some details, you want ISS be closer to you and also with less atmosphere as possible. I didn't know about this, but I was preparing this presentation. I kind of searched up more information about the ISS. And because of the orbital inclination of 51.6 degrees, if you live beyond 51 degrees north or south of the equator, ISS will never appear directly above your head. Good that we are at about 45 degrees altitude. So sometimes, yes, especially in May, June, ISS could be way above your head when it passes. So that would be a good thing. How do we know when ISS be available, be observed, to just observe or for taking some pictures? Heavensabove.com is a very good website for you to check out. There's a desktop version, or you can actually download on the mobile app. Astrospheric.com is also one of my favorite apps to check the weather forecast, and also it gives you the upcoming notice about when ISS will be available for observation or for taking picture in the sky. Here's a screenshot for heavensabove.com, and the next ISS pass through, I think is the good one, is actually January 3rd. Oh, actually, tonight. Oh, it's already passed. Okay. Yeah, so yeah, you can see the highest point, the altitude of it, And so if you actually go to the web link, you just click on this one of these dates, and you have the whole map showing to you where and when ISS is observable during that time. And you'll find that most of the time is actually early in the morning for a reason. Okay, so of course we cannot observe ISS during the day, but in order to see ISS, the space station must be reflecting the light from the sun without getting into the shadow of the Earth. So we rarely see ISS near midnight because, you know, around the midnight time, the Earth shadow will be, you know, right above your head. And when any satellites, you know, to pass through the Earth shadow, it won't reflect any light for you to see. So it will be shortly after sunset or shortly before sunrise. This is another app that I always have on my phone, astrospheric.com. And you see that when you see this little icon here, you can actually click on it and you'll see the map and the time when ISS is available in the sky. So the challenge of taking picture of ISS, first of all, and the biggest challenge is that it is a moving target. It is like, you know, how would you take a picture of a moving race car? Of course, it's not as fast as a race car. I have a video to show you how fast it actually moves across the sky. But there are many other uncertainties, and I had to really test run it and try different things and take your own notes and then come up with my own strategies. There is uncertainty in exposure time and the shutter speed. I found that at different altitude of ISS, the brightness changes so much. So when if you want to take a good picture when it is a higher altitude in the sky, you have to kind of estimate like what is the best exposure and the shutter speed for that moment. Of course, I screw up so many times, but I have my own number. I can share that with you in a second. The field of view is extremely small. The field of view I'm talking about is how much space in the sky the camera and my telescope combination is actually capturing in the sky, not the size of the ISS. So if you look at, you know, if you stretch your hand, if you look at your pinky, that's about 1 degree. And the full moon is half a degree. So if you stretch your hand, you look at your pinky, the size of the full moon is probably around half the width of your pinky. And the field of view of my camera and the telescope setup is about 1/3 of the size of the full moon. It's extremely, extremely small. And the size of the angular size of the space station is about 63 arcseconds on average. It is 1/30 of the size of the full moon. And it is moving. It is moving in the sky. So can we track on it using computerized program, using software? Yes. And I'll share that with you in a second. But there's a problem with my setup that I couldn't use any software to track it. And also the sky condition is another big factor. This is what we call the seeing condition. It is very critical for planetary imaging and also especially for ISS. But for ISS, it is actually a lucky game. Like if you can track it well, you still have the luck to get a good seeing condition for that critical seconds if you want to get some good pictures. And I live in Stouffville, which is close enough to Toronto. You know, the sky is actually pretty bad, and the atmospheric turbulence is really, really bad. So that's why I have to keep trying and trying until a moment that it is good seeing, and then for the few seconds I get some good captures and I can get some good pictures. So let me share with you what equipments that I'm using currently for my ISS pictures. I use the mono camera Player One Apollo M Max. The size of the pixel is about 9 micrometer. It is a camera with pretty big pixel size, relatively, but it has a really very sensitive sensor, so the frame rate is actually pretty good. I've tried different cameras before. I had a Mars C, which is a color camera, and a Mars M, a mono camera, but so far I've tried different settings and different cameras. the best result is using Apollo MX with actually a 3 times Barlow, which is like a 3 times the focal length of my telescope. And you need a camera with a high frame rate because again, it is a lucky game. And you need a high frame rate. Hopefully, if you get a couple of frames that are good, then you're all set. You can go into processing and you can try to sharpen it and so forth. Also, I need a 3x Barlow. Barlow is basically a focal extender. So the focal length for my telescope is 1,650 millimeter, 1650. So with this Barlow, it would make them times 3. So basically, we are talking about 4,000-ish focal length with that camera, because I need that, because the ISS, the angular size is actually very, very small. So here's a telescope, some of the specs. I have the focal length here, and can we track it by the mechanical motors there? Yes or no? But I found that there's no room for error. That's why I had to track it by hand. And I'll explain to you why in a moment. And so you can see the field of view using astronomy.tool, the website. You can see the field of view is actually 1/3 of the diameter of the moon. The moon is about half a degree. This is 0.137 times 0.12 degrees. So, and ISS angular size is even smaller than that. And so I mentioned that already, you know, the pinky, if you stretch your arm, that's about 1 degree. So imagine you divide from east horizon to the west horizon into 180 degrees. So if you divide this by 180 parts, 1 degree would be the size of your pinky when you stretch out your arm, and the moon is about half of that. And you can see the size of the view is extremely, extremely small. Software that I use Fire Capture, which is a great planetary and ISS capturing software. It is totally free, and I like Fire Capture for planetary imaging because it has a very unique function, which is auto-align. This button here. So sometimes the tracking is off a little bit, but if you actually select the right ROI, the region of interest, you can digitally center the target dead at the center with some room for errors in tracking. So you can actually save a lot of time for processing for planetary imagings. But I'm not talking about planetary imagings today, but I'm just sharing with you, this is the software I use to capture my picture. Now, so how fast does it move in the sky? Here's my telescope. I was hand tracking on it. Now you see that there's a dot above the tree. Now it's more visible. That's ISS. That's the International Space Station. So this is in real time. You can see the timer. It is in real time, and that's how fast it is actually moving across the sky. So from the time it is visible until it's got hidden by a house, my neighbor's house, it's about a minute time. So you see the ISS is moving in the sky. I was trying to track on it, trying to put it at the center of the frame of my setup, and yeah, sometimes it will disappear in the middle of the sky as it goes into the shadow of the Earth, but sometimes you can see that for like most part in the sky before getting into the shadow. Right? So now is above, almost at the highest point in the sky. So manual tracking is my strategy, and I learned from failure. Just like anybody who started this hobby, this learning curve is so steep, you know, you have to fail so many times to get something decent. So I learned myself, you know, from the failure experience, from bad alignments, from wrong exposures, altitude was too low, and I learned that. And dual problem, especially during, you know, sometimes when the temperature is too cold, I found, how come I don't see anything? Oh, because the mirror is actually all fogged up. And I didn't realize that. And I misread information from heaven above sight. That's actually pretty interesting. One night, I think it was just last year, I was looking at heavenabove.com, and I printed out the information, and it predicted that, oh, ISS should be in the sky at around 4 a.m. So I set it up, before I got to bed, and I woke up at 3 o'clock. I tried to get everything set up. I was so excited. The sky was so clear, crystal clear. And I waited. I didn't see a thing. I only see star in the sky. Where was ISS? I thought I misread the date. No, it was the right date. How about the time? Everything was correct. But that was actually, I misread the information where the whole ISS was actually inside the Earth's shadow. And I didn't know that. I have to double check different sources of information to confirm, yeah, it was really in the shadow. So, yeah, I learned from that because I was so excited. I was so ready to send good pictures. It was like 87 degrees up in the sky. The highest point is almost right angle. And in theory, that should be the moment where you can get the closest approach. And the sky was like, the seeing condition was so good. I disappointed, but I enjoyed that, and it was just a learning process. So when I talk about alignment, what I meant was that, you have to use the guide scope at that time to line up with the main scope such that, because I was only guiding with the guide scope for the first year, and the problem is the guide scope was left and right, top and bottom flipped. And it was really confusing. Like, I know the ISS was going up, going higher and higher in the sky, but when I look at the finder scope, when I moved the scope up, it actually went down. And when I move left, it goes to the right. So it was so confusing. And then I searched up on internet, okay, what do other people do? And then, okay, I understand now because they were using a turret. And the one I chose is the Explore Science Reflex Sight. It is what I use now to track the ISS. So the alignment was this little dot right here. So I recognize this dot, it is the lowest dot at the inner circle. I have to carefully align this dot to a very far target. Make sure that if ISS passes through this dot, it must be captured in the frame. All right, I have full confidence that when ISS is passing through. So imagine my laser dot is the ISS. Sometimes it just passed like that. I know that it's not good. And if I move the scope again, it may just go to the right. Sometimes I see that, oh, if ISS is in this path, I can actually, now it's passing through this dot. Then I capture that for that split second. So here's my routine, precisely align the finder scope and the turret ahead of time. Everything set up, the focusing has to be dead on, and don't touch it afterward. And make sure there's enough storage space in your laptop. I have an external solid-state drive for storage purpose. You need to have at least 50 gigs of data for that night. And set exposure, time gain, and other parameters. And when you see ISS starting coming up from my neighbor's house, then I start tracking on it. And I found that only when ISS is 65 degrees or above the sky, I could get some better than average pictures with the help of good seeings. And my setting here is that, with the 3x Barlow, with my setup and the camera, half a millisecond exposure time, gain 210, and I have about 135 frames per second. How does it actually look like? And I have a short video to show you in a second. I know the time is short now, so let me just quickly go through some of the key events I prepared to show you here. During my first attempt, I took 18,000 frames. For that, a minute and a half or 2 minutes passed by. ISS only appeared in 1% of all the frames. And the funny thing is, I didn't know there's software out there that can help you locate the ISS from all these 18,000 frames. The first time I did it, I spent 5 hours looking at each frame one by one. It was painful. I tell you, again, I learned from mistake, and I thought if there's a problem, there has to be a solution. So go online and ask people, and then now I have the solution. I'll share with you what software that can actually save you hours of time on looking at all the frames. Only 7 frames were useful. But still, that 7 frames will give you some, like my first picture I will show you in a second, is blurry, but I was so excited when I first got the first picture. Second attempt, better. And I have 15% of the overall frames with ISS in there. However, not all the frames are useful. Right? I get relatively more useful frames, but not all the frames are useful. So this is called the leapfrog style guiding technique. It is that when you predict the ISS is coming to your direction, you kind of move it ahead of time, and then let ISS passes through this dot. So I have to move forward, stay, move forward, stay, move forward, stay, and so forth. This is called the leapfrog style guiding. And because of hand tracking, as I said, I spent 4 or 5 hours just looking at the frame. Now I know there's a software called PIPP, which is a free software. It looks something like that. It can actually detect here, object detection, because most of the frames are just pitch black, because ISS wasn't in there. But it can actually scan all your thousands of frames and just take out the frames with ISS in there and crop it and center it for you. That saves you so much time. And here is the first raw video. The seeing was bad, but look, here's the ISS coming closer and closer and closer. That was overexposed, I can tell already. This is overexposed, but you see the solar panel, right? This is from the program that is searched for the ISS pictures, all of these hundreds of thousands of frames, and they just put maybe like 200 frames with ISS in there and put them into like a video. And the second video is slightly better because now I adjust the exposure. It is no longer overexposed, but you can see that at one point it was a little bit clearer than the previous video. Maybe it's around here. It was much clearer. You see the SpaceX capsule is the top black stuff here. Okay, the top white stuff here. Here is the SpaceX, the docking port. And yeah, so the quality is not that good through YouTube, but it was a better capturing moment. So the seeing was okay. So all I need, in summary, for taking ISS picture is just some luck, because I just need a few adjacent frames with good clarity, with good seeing, especially when it is near the highest point in the sky. That's all I need. If I capture ISS low in the sky, it's not useful. After you pass through the highest point low in the sky, it's not useful. Only when it is at the highest point in the sky, it is useful. I only need like 2 seconds of clear sky. That's all I'm asking for. And so if I'm lucky, if I get a few good frames, then I will proceed to processing the pictures, try to stack a few of them together and sharpen it using a freeware IMPPG, and then use Photoshop to clean up the noise and to just sharpen everything. So this is my first attempt. I was so excited to get the first picture, 2022 May, and yeah, so again, there was only 1% of the frame found from 18,000 frames. I think 7 of them are useful, and I got something like that. At least I see some details, and I was happy about it. And second attempt in May 14th, 4:30 a.m. Now you see, it's better. And at least I see some clarity in the picture. You see that, but it is still overexposed. So I was thinking, like, what do other people use? So I try myself and look up internet and what other people do, and I come up with a slightly better picture in May 29, 2022. I can actually identify many of the features of ISS. And then in July 15, my 5th attempt that year, it was great. Like, this picture is slightly better. This picture is actually with an altitude of 87 degrees. So it's almost directly above my head. And so that was the ISS picture. This year, May 28th, My 7th attempt, finally got a clear sky, a little bit better altitude. I got this picture. And yeah, you can tell it's actually so much better. No, thank you, thank you. And my 12th attempt this year in July 27th, and it was a black and white picture indeed. And I thought, okay, black and white doesn't look realistic, and I use an AI platform to colorize it. And I honestly, I shared that when I shared this picture on social media, I say, this is not the real color. I did not use a color camera, but I used AI to add colors on it. So it looks more natural. And this is a link for the AI platform I used. So if you have any black and white picture, you can actually upload here. It will make it colorized, and it's cool. It's cool. So yeah, that's my 12th attempt this year. And can we track it mechanically? Yes, there are software that can actually do that. So first, this is the Skywatcher mount software for satellite tracking. So it is designed for tracking satellite for any Skywatcher mount. And another software is called the PreviSat. It is another software available out there for free. And Skytrack, I think this one you need to pay a very small amount to have the full function after 2 weeks. But yeah, I tried this and it works. And it works. It works, yes, when I'm observing the satellite just visually using a low power eyepiece. But I found that the satellite is still moving back and forth in the view. How do people track satellite using mechanical software and machines and software? They all use a high-end tracking mount, like very expensive high-end tracking mount. And because I have no room for error, because remember the ISS is so small, the field of view is extremely small, I know that when I can track it visually, I know it doesn't mean that I can capture it using my camera. So I have to give up the software option and track it by hand. I found it that it's more reliable. And so that's why hand tracking is the way I go. If I have more high-end tracking mounts, maybe I can go for the software with photography. Look at this. Compare my picture with this picture. Like, there's no limit how good you can actually take. This is not from me, but this is the best ISS photo I've seen to date on social media. This is by Michael Zuccaran, and he's one of the famous ISS photographers out there. He got like amazing, amazing pictures. Look at this detail. I didn't know, like that star thing on my picture actually has features on it. This is amazing. So this is very inspiring to me because they're using similar equipments that I have, but we can only do better and better in this hobby. This is just in any domain in astrophotography. So with the Dobsonian telescope, I can take picture of different planets. This is my Jupiter picture. You can see the seeing has been pretty good. This is the actual view on my computer. There's no jumping around because the atmosphere was so steady and it was great. So that's why I got a pretty good picture for Jupiter that day. Yeah, so I was using my 8-inch Summit Cassegrain for some of the pictures until 2022, upgraded to a Dobsonian. So yeah, it was a great journey for taking picture of planets. Also Saturn. This is my latest picture of the Saturn. As the ring is getting closer, the edge is getting closer and closer to us. It may disappear from the view in the next few years. Mars, during the opposition last year, December, it was so close to us, and I took the opportunity to take some good pictures of Mars. The Mount Olympus is right here, the tallest mountain in the solar system, Mount Olympus. And Uranus and Neptune, it is also possible with the clear sky. So that night, I actually took this picture, this one, Mars, and Uranus and Neptune all in the same night. Because the sky was so clear, I didn't want to give up that opportunity. So of course I didn't sleep. And I had to work on the next day too, but whatever. It was a great experience. And so there's some of the specs right here. And what about deep sky object? Yes, Dobsonian is actually possible for taking photos of a deep sky object, but the exposure has to be very short in total, not just the every single exposure. This is 60 times 1 second. That means each exposure is 1 second. I stack 60 of them together because there's something called field rotation. That means that the field, the view will basically rotate after time. And it won't work if you have a long exposure, unless you have something called a field rotator. It's a mechanical thing that you can actually purchase, and it will derotate the camera for you automatically. M57 ring nebula using my Dobsonian. Again, this is 60 times 1 second. It's fun to play with it like that. Yeah, so it is possible, but not ideal for deep sky photography. And yeah, sorry, I overtime for 10 minutes, but thank you so much for your attention. Is there any question about taking pictures using this telescope? Yeah. Thank you. So there's a question right there.
Well, I walked there. I want to say fabulous images and great presentation.
Thank you.
Really well done, Benjamin.
Thank you.
Okay.
So you said that you need good photos over 65 degrees, and so not counting bad weather, how many kind of times in a year is it possible over 65 degrees without it being in the moon's shadow?
This year in 2023, I think I had like 13 times. No. If it is above 65 degrees, just a few, less than 5. Because sometimes it's not clear, it's cloudy and everything, right? And there's a question there for the gentleman there, back there, with the red shirt.
Yes, I'm curious about moving and tracking manually because when I try to do this with my scope, this 8-inch, everything is vibrating.
Yeah.
How can you deal with this in your Dobsonian?
I took a deep breath, hold on to it. I didn't breathe, really, for most part of the tracking. So I took a deep breath, just staring at it, using the alignment, and then just track it. And I have to like really steady. I found that I cannot loosen all my knobs. I have to tighten a little bit, maybe 10%. So some friction can actually eliminate some of the vibrations from my hand. Yes, there's a question here.
What was the shutter speed you used?
Shutter speed is about half a millisecond for some of my pictures, 0.5 milliseconds.
I have two questions. One is, how does the angle to the sun affect the picture? Because obviously different things might be illuminated. And the other question is, would it be a real challenge or is it impossible to get a picture of the ISS when it's actually in the Earth's shadow?
Now, I don't know. I don't think there's any way to take a picture of ISS when it is in the Earth's shadow because it is not reflecting any sunlight. And to your first question, I can only say that I have seen different configuration of ISS. Sometimes when the solar panel is directly facing me as an observer, everything will be overexposed. And I found that the best exposure is that when the solar panel is not directly facing us, and maybe at 45 degrees, and my exposure will work. So it's a lot of try and error, and I hope there's a recipe telling us what to do, but I haven't found any. So lots of people doing the ISS photography, they're always trying and error and see what works the best.
Questions online? Yep. Okay.
Frank Dempsey comment, great work. Question, tracking a Dob near the zenith is easy or is it the worst position for tracking? Is it easier to track further away from the zenith?
My experience is that it's actually easier. It's actually easier because instead of moving up, before and after the zenith point, you basically just move the scope horizontally, kind of, right? Because the arc is like that, and there's not much motion, in the up-down direction. So to me, it's actually, because if you know the path is going to be like an arc, if you can predict that, you can actually move the scope ahead of time and let it pass through the center point of the alignment. So I personally found that it's easier at the zenith point.
Copy that. Okay, that's a great answer. Comment from Rain Lang. Super strategy, process, and diligence. Great that you strongly focus on few goals and achieve so much success in photography, photographing your treasure, the ISS. Cheers.
Thank you, thank you. Thank you so much.
Any more questions? Or Benjamin? I have a question myself, actually. Great planetary images as well. Beautiful. And deep sky, too. I wanted to ask you about the deep sky images. It was only a 1-second exposure, but your telescope mount was tracking at the time, was it?
Yes, it was tracking.
It was, okay.
It was tracking.
Okay, gotcha. The reason I was asking is I did attempt that with my Dob, which is not motorized, and even 1 second you get a blurred image.
Well, even my tracking Dobsonian, I found that if my exposure is 2 seconds, the star already moved, because the tracking is actually not stable.
That's right. Okay. Very good. All right. Thanks again. Great presentation.
Great. Thank
Benjamin.
you. Thank you.
And we'll take a short break while we go to prepare for announcements.
So, as Paul was saying earlier, we've got two types of meetings here. We've got our Recreational Astronomy Nights, which is what we've just had this evening. And then coming up in 2 weeks online is one of our speakers' nights. For those of you joining us live on YouTube, please say hello. Enter some questions for the presenters, as others have already done. If you're a new member, please introduce yourself. And if you're coming to us from far outside the Toronto area, please let us know where you're joining us from. So we're still waiting for the final details of for our speakers night, which is going to be in 2 weeks online here on YouTube. Coming up on our next Recreational Astronomy Night on the 7th of February, 7:30 p.m., both in person here at the Science Center and online. The sky this month, details still to be announced. Ron McNaughton will be discussing how the ancients predicted eclipses, and as Paul said, we've also got one empty slot available. So if you want to give a talk, give Paul a shout. And further enticement to actually show up in person. For the solar eclipse coming up in a few months, almost weeks, we have free solar eclipse glasses. So please, you can't get these online. So by downloading, you cannot get these by downloading these off of YouTube. So you're gonna have to show up in person. So they'll be available at each of our recreational astronomy nights to pick up. And speaking of observing the sun, solar observing here at the Science Center is going to take place this Saturday, the 6th, from 10 a.m. to 12 p.m., just outside the building. As always, this is weather dependent. You know how that's been lately. So please check out our website for our go or no-go call prior to heading out. So, and our City Star parties, furthermore towards the weather, the City Star parties at Bayview Village are on pause until April because the city doesn't plow the walkways in Bayview Village Park. So we're waiting for any snow that's going to show up to melt before we restart those in April. Long Branch City Star parties are going to be not really scheduled. They're going to be when really conditions permit. So if it's a Friday, Saturday, Sunday, or a holiday evening that's really clear, which also means really cold, and if the conditions are safe, like the ground is not covered in ice or tons and tons of snow, then check out our website to see if we're going ahead with one. Coming up to DDO in the next little while, we have Astronomy Family Night on Saturday, January the 19th, 6:30 to 8:30 p.m. Registration fee as shown here, and links for registration can be found at raskto.ca. And then coming up on the 21st is virtual Sunday sun gazing, so online only, registration fees and links at raskto.ca. The CAO is open. If you didn't catch the announcement at our last meeting, we have now arranged for the road to be plowed in winter. So what's going on? We hopefully can now turn the CAO into a real all year round observatory, and not just for the really intrepid people with snowshoes. Operations are largely back to pre-pandemic conditions, but there's a couple of exceptions. The main one being that there's a maximum of only 2 unrelated persons per bedroom in the building who mutually agree to share that room. Masking in common areas is encouraged, but the preference of the people in attendance will be taken. Public outreach events did get restarted in the last year, and we had supervised weekends all through the summer and the fall. Please take a look at the online CAO bookings page for details. And please read everything before making your booking. Got some open job postings. We are looking for a chief editor for our Scope newsletter. So if you like to edit and write, it's a bi-monthly publication, and we send out to all of our members online. And if you're interested, we will send you a hard copy as well. Contact the volunteer coordination at volunteer@raskto.ca or myself, the president, at raskto.ca. We're also looking for a volunteer committee chair, a marketing committee chair, and some committee members. And EPO is always looking for additional help, especially online presenters, telescope camera operators for virtual star parties. And as always, thank you very much to everyone to the folks who reach out from the general public who want to help. But in order to volunteer, you first must be a member of the RASC. So drop me a line at president@raskto.ca if you'd like to help. Quick plug for RASC membership. You can renew and sign up online at secure.rask.ca. Just a reminder, membership is dealt with by the national office, not directly by us. So if you've got an issue or want to talk in more detail, contact the national office directly. It's rask.ca as opposed to raskto.ca. And gift memberships are also available from the national office at mempub@rask.ca. And I'd like to invite everyone here to what we like to call the meeting after the meeting. The Granite Brew Pub at 245 Eglinton Avenue East. That's the southeast corner of Eglinton Avenue and Mount Pleasant. There is free underground parking accessible off of Mount Pleasant Road. We are usually in the front room. I regret to say I can't join you this evening. Real life gets in the way. I've got a place to be early tomorrow morning. But for everyone else, I'd like to wish you all a very pleasant evening. Thank you very much for joining us. Please follow us on all the forms of social media that we've got listed here. If you've been watching us live on YouTube and you like what you see, please like and subscribe, hit the notification bell. And thank you very much, folks. Be safe and keep looking up. Good night, everyone. So does anyone want some eclipse glasses?